Okay, again, this will be multiple choice. It says state the postulate that can be used to show each statement is true. The first one says the planes J and K intersect at line M. So this is plane J and then plane K, and it intersects at this line M. The postulate for that is if two planes intersect, they intersect at a line. So just writing that down, if two planes intersect, they intersect at a line. So that is in lesson 2-5, and there's more postulates there that could show up on the test. And again, it will be multiple choice, but you may want to review those postulates and just make sure they're fresh in your head so you're familiar with them. Then in lesson 2-6, we were introduced to some of these. This says choose the property that justifies the following statement. It says if x equals 2 and x plus y equals 3, then 2 plus y must equal 3. So in this case, they're taking the 2 and plugging it into the second equation, and that is substitution. Number 3, it says measure of angle A equals measure of angle A. Anytime something equals itself, that is reflexive property. Number 4, choose a property that justifies a statement. If segment GH is congruent to FD, then FD must be congruent to GH. They're just flipping it. It is symmetric property. And then the other key one that may show up on your test is transitive. Again, just review lesson 2-6 for those. Okay, now number 5. There aren't a lot where you actually have to solve for something on this test, but this is one that you may see, and I didn't trick you. There's going to be one just like this on the test, but with different numbers. So it says measure of angle 1 is 3x plus 15, and it says measure of angle 2 is 6x plus 3. It wants you to find the value of x. Well, in this case, you have vertical angles, so therefore they're equal. They're congruent. So 3x plus 15 equals 6x plus 3, and you can set that up to solve for x. Then from here, just solve the equation. And I get x equals 4, and that's the answer. In that case, they just asked for x, they didn't ask for the angle measure. If they did ask for an angle measure, you just take that 4, plug it in to one of the expressions, and you'd get the angle measure. Number 6. It says if measure of angle ABC is 34, ABC, so it's talking about just this right here, 34 degrees. Find the measure of angle CBD, so this one right here. Well, we can see that they come together to create a right angle. So that means these angles must be complementary. 90 minus 34 gives us 56 degrees. So measure of angle CBD equals 56 degrees. Okay, so now we're going to start working through the proofs. If I'm going too fast, let me know. If I'm going too slow, let me know. I'm going to try to go at the perfect pace where it doesn't get too boring, but you can keep up with me as well. So, starting with the first one, the first thing you would do with a proof is put the given in that first blank. So here, angle 1 is congruent to angle 3, and I'm titling that given. You can see the answer bank at the bottom and just cross things off as you go.
Or what I did is draw arrows to the respective box.
We'll do that a little bit as well, but if it can kind of fit in the box, just write it there. Then,
unless you write big.
then angle 3 is congruent to angle 2. We can see that those are vertical angles, and that's why they are congruent, so vertical angle theorem. And I abbreviated a little bit there. And then the last box should be our prove statement. So I'm going to copy that here. And if 1 is congruent to 3 and 3 is congruent to 2, then 1 must be congruent to angle 2. And that is transitive property. Okay, then we're going to move up to here. This is one that we saw on the workbook. For the given, it gives us 3 lines, and there's quite a bit of given. I'm going to abbreviate. It says segment AB is congruent to DE, and then it tells us B is a midpoint of AC, so I'm just going to write B midpoint and E midpoint. Again, you would be dragging and dropping that into that spot. Okay, let's see. Then it says AB is the same length as DE. We have the congruent statement here. Now it's saying it's the same length. That is definition of congruent segments. Next, it says definition of midpoint for the reason. What it is looking for there is, since B is the midpoint of AC, that means AB is congruent to BC. So AB is equal to BC. And since E is the midpoint of this segment, that means DE is equal to EF. Yeah. Trying to keep the picture in there too, though. Okay, so then what they did here is, since AB is equal to DE and AB is equal to BC, they took BC and plugged it in for AB. So that is substitution. Then they repeated this, but since DE is equal to EF, they took EF and plugged it in here. Again, substitution. And last but not least, they're almost at the proof part. They just need to turn this into a congruent statement. BC is congruent to segment EF. Definition of congruent segments. Okay, the next one. Okay, we have the given. AB is congruent to CD, and BC is congruent to DE. So it's saying this is congruent to this, and BC is congruent to DE. You will turn it in tomorrow. So you'll take it home with you to study tonight, and then you'll turn it in tomorrow during the test. Then from here, to go from a congruent statement to just the length equals each other, we're going to say AB equals CD and BC equals DE. So I'm crossing this out, crossing this out. Then here it says AB plus BC equals AC, and CD plus DE equals this entire length. That is segment addition postulate. And then we have CD plus DE equals AC. They're using substitution. And then they are using substitution again. Since this is equal to EC, they're plugging that in there. Substitution. And then last but not least, they're turning this into a congruent statement. And definition of congruent segments.